I wanted to kick that out of your hand so bad. All right, so to catch you up to where we were last time, we mocked everything up. We had everything tacked up. Everything's welded up and done for the intercooler piping. And we even got into putting on some fittings for the coolant. So we're ready for our next step, which is to work on the rear end. So I'll bring the car up, show you what we did in the back. We've cleared out most everything, but we know that there's a lot that has to be cut out, modified, and you can see how big this factory subframe, diff and stuff is, but we're ditching all of this. We need none of it. We're not using the brakes, we're not using the diff, axles, arms, any of that. So we also cut out the trunk. It's just to give us a little more clearance for what we're about to do, which is put massive rear end in this thing. We got a winner's quick change, and we got the guys from Key Automotive here to help us out. I'll introduce you to the guys, and we're gonna get started working. All right, so as I mentioned before, we got Mike and Adrian here from Key Automotive. We brought them in to help us out with everything that's going on in the rear end. It's above our knowledge. These guys are really well versed in Camaros. That's what your shop is based on, right?
Yeah, so we build 5th and 6th gen drag race Camaros. So like a solid axle conversion was kind of right in our wheelhouse to come in and help you guys out with.
Yeah, that's something we've never done. So you're one of the main fabricators, correct?
I am, yeah.
So you're here to help me on stuff that I can't do.
Yeah.
You're gonna guide us through everything.
Yeah.
Get you straightened out.
You guys have built some massive drag cars, some really quick stuff. What is all involved in this kit that you brought for us?
Yeah, so we got everything here to be able to put like a 4-link rear suspension with a panhard bar in it. So we've got everything from the chassis side brackets to the axle housing brackets to the upper and lower control arms, panhard bar, and all the bits and pieces and hardware to put in.
Let's just walk through the kit a little bit and show us what we got going on. It's just so light.
So we got upper control arms, adjustable, lower control arms, fixed length. We've got your lower control arm mount, that's chassis side. And then up front here, this 2-inch box tubing, that's our frame rail connectors. So those are gonna go back from these into the front unibody structure.
Okay.
Kind of tie that all together. Mm-hmm. This is gonna be your upper control arm mount. So we actually can locate these in the vehicle using the rear seat belt mounts. So that'll go in there, and then we're gonna tie that in with your roll cage to give the strength and structure from your roll cage.
That's pretty cool that you have that set up. Good thing we didn't get that far into it and wait until you guys got here.
Yep.
Because I was gonna start prepping stuff, and it turns out it would have hurt a lot. And then the upper mounts there are really sweet.
Yeah, so this is designed to kind of mimic the production upper shock mount.
Yeah.
So it's designed to go right in the shock pocket there. It's a machine piece with a spherical bearing welded to this plate. Goes right in. Your shock manufacturer will be able to kind of get some dimensions, go right into this.
Make it super easy for them, yeah. So where do we begin?
Basically, we're gonna remove some sheet metal from the bottom of the car. So,
It's the most fun part.
yeah.
Just drilling out spot welds?
Drilling out spot welds to kind of get us access to areas that we need to mount our fixtures up. And then we'll take some dimensions off some fixtures, and basically we're gonna set up to graft a lower control arm mount into the factory frame rail. Is basically where it goes.
All right. Well, I'm ready to get started.
Let's do it.
All right, we'll get started then. Next up, mount the rear end and bolt it up and get you guys out of here. All right, so this is the diff we were talking about. It is a winner's quick change. This is a very important piece for us because it was hard to find a gear set that would actually get us the wheel speed we want. So this is a 2.0. and that's not easy to find. We couldn't find it in 9.5, so we went up to this big beast here, and that's why we need you guys to mount it up, because we're gonna be making a lot of torque with this bad boy, and we don't want it to walk around, and we wanna go straight.
So we brought the brackets that we typically use on like our fabricated housing, and we worked with you guys. I got the tube size so that we could kind of pre-make them and get them out here. So we've got this bracket here for the upper control arm. We'll figure out kind of the dimension we need to come from the center line, and then whatever rotation it needs to be. You can see it fits on there real nice. We've got a similar piece here for the lower control arm. Process is the same, dimension and then rotation. And then finally, this piece here will be for your rear shocks. And that actually ties into the lower control arm, but we'll have the dimension and the rotation.
So just a little bit of science, a little bit of welding, and then we throw this thing in?
Yeah.
All right, let's get to it. All right, well, I'm pumped. It looks amazing. It's actually sitting in there, like kind of under its own power, aside from our fake suspension we have, but it looks great. I really like it.
Yeah, it's different than what we typically do with the housing back there, so it's pretty cool to see this in there rather than like a fabricated piece.
Yeah, and for a big beefy diff, it actually fits in there. I thought we'd have to trim a bit more, which we will. We'll have to trim some, but not like I thought we would. We got a few more things to do, but really simple. You guys knocked out all the stuff that I was worried about, and the stuff that I couldn't do myself, so pretty rad. Let's show off this masterpiece, what you guys created here. This went so much better than I thought it would. I was really, really scared of this whole rear end process, but talking to you guys the entire time, you're super confident, came in and finished even faster than what they said. But it mounted up really nice. Everything looks great. Adrian, great job with that.
Thanks.
Thanks for the help, Mike. I could not have done this. We got a few more things to do as far as like changing out this fake suspension that we made to hold this in place, and a couple little braces and pan hard bar. But it doesn't stop here for us. As I've learned from talking to you guys this weekend, found out that they could help us in a couple other ways, and I'm not about to do more work than I have to if these guys have already figured everything out. So thank you guys so much. I could not have done it without you.
Thanks for having us.
And we will be in touch because I need more help, but pretty pumped at how this is turning out. So we're ready to move on to brakes. So we got Eric here from Stoptech, who's gonna help us get this thing ready to stop. And if it doesn't, then I'm in big trouble. So we called you guys because the factory brakes aren't gonna cut it. So what did you bring us?
We brought you a 6-piston 15-inch front package and a 4-piston 13-inch rear package. Should have no problem stopping this thing from 200 miles an hour.
Amazing. That's bigger than my wheels most of the time.
Yeah.
So we're gonna take a look and compare the side by sides.
Sounds good.
All right, so the first thing I see is just the size difference between the stock fronts. It's insane. Like, these are massive compared to the factory.
Well, when you're going fast, you're going to generate a lot more heat when you brake. So the rotor acts like a heat sink. So the larger your rotor is, the more heat you can absorb and then radiate back off. There's also a lot of features with regards to the metallurgy, improving the bite of the system. The slots also help to improve friction. We also do a curved internal vane design. So this is a directional left versus right, where you can see the OEM rotor has a straight vane. There's no directionality to it. Yeah. So we actually have a patented internal vane structure. It's called our aero vane system. So we have sort of an airfoil shaped design that actually helps to accelerate air through the rotor to improve cooling.
That's really cool. See that in there.
Yeah, and so we're also doing an aluminum center hat, which helps to reduce the weight. So even though this part is quite a bit larger than the part it's replacing, it's going to be actually just a little bit lighter than the stock part.
It really is. That's crazy, because visually you'd think that's going to be way heavier.
Right. Well, I mean, the weight's in the right spot, and that's what really matters. You need weight in the brakes, but you want it only where you need it.
All right, let's get rid of these.
Right, so we brought our 6-piston trophy. So this is our STR60 caliper. You can see, first of all, 6 pistons, of course. We're going to spread the force out across a wider area on a larger than OEM pad. So this is your brake pad that you're going to be using. We also do what's called differential piston bores. So as you wear a brake pad, as it heats up, the leading edge of the brake pad will wear faster than the trailing edge. So when this is mounted, the rotor would be spinning like this. This leading edge of the pad would actually wear more quickly. So what we've done was we run a smaller leading piston and a larger trailing piston. And what that does is it puts more force on the trailing edge of the pad to overcome that wear characteristic, and then you get a more even wear rate across the pad.
Well, that's something that I've not seen. I didn't know about, so that's
a lot of the OEM calipers don't use that because it requires a dedicated left and right caliper. So even if you have a multi-piston, like a 2-piston slider where there'd be 2 smaller pistons, they're typically the same size. All right, and the caliper will just slide right onto the studs. Right in place. And the brake pads just drop right in through the top of the caliper. So, yeah, get that mallet. And there you go. Just tighten them up with an Allen.
Yep.
Pretty much all set.
That's awesome. Looks so much better. All right, so fairly straightforward, quick, easy. I mean, it's a bolt-on kit. So
what it's made to do, yeah.
Yeah, huge
design.
upgrade. Looks great. We're gonna bolt this up. Jose's bolting up the other side, and we'll move to the back. A little bit more custom work. All right, so the back is completely different. Everything's custom. None of this is factory. We got our quick change.
Right, so the C43 calipers that we showed earlier, we've gone ahead and pre-assembled them, installed the pads, installed the bracket. What that's going to do is help to determine where you're going to need to weld on your mounting bracket.
So this bracket here, which is what we showed on the table earlier, like this is going to have to be bolted.
Right, so this is a universal 3.5-inch mount spacing, and what you'll end up doing is getting some tabs that you'll weld onto the axle shaft itself, and from there it'll key up to where the caliper is going to mount. So ultimately when you're done, your caliper is basically going to be sitting looking like that, and you're going to be welding up your brackets.
And we've got plenty of clearance everywhere else, so there's nothing really to worry about there. So just one more little piece to make, and then we're done there.
Run some brake lines, and you're ready to stop.
This stuff just looks fantastic. Thanks for keeping me safe. I'm sure we'll see you around.
Sounds good.
So Eric's going to show us around today, and we're going to take a tour of the whole Stoptech facility, see what the process is.
All of our dynos have a complete environmental control system on them, so we can manage temperature. We can also really limit the noise coming out of the dyno because it can be real disruptive. So this test right here is probably just for noise, vibration, harshness, and wear. So it's probably a street pad that's tested to just get an idea of how long it's going to last under certain usage conditions. So we're pulling temperatures out in real time. We can watch the graph and see what everything's doing and get an idea of things like fade, whether or not the material is starting to break down and deposit unevenly on the rotor face.
So this will test for speed and stuff as well.
Yeah, so we can actually plug in data from like a race car. We can pull the telemetry out of a race car, put on a big brake kit on the dyno, and actually replicate what that race car would have experienced. That, like, you know, we could do 50 laps at Laguna Seca in a Porsche Cup car with the dyno, and then get fairly equivalent results, close enough.
So that thing gets moving pretty fast.
You know, we do armored vehicle testing as well, so those are 12, 15,000 pound vehicles. And we can do testing of vehicles of that weight up over 100 miles an hour to create insane amounts of energy.
Kind of how I feel like we're going right now at the moment.
Camaro's going that route.
The Camaro's going to be a lot heavier than what it was, and it's going to go a lot faster than what it was.
And a lot of weight over the front axle that wasn't there.
Right,
so.
yeah, we're playing with a lot there.
Yeah.
That's cool.
So let's hit the machine centers.
Wow.
Yeah, so when it comes down to racing rotors, we're doing a lot of our rotor machining in-house. So this is a raw rotor casting. So this is like a universal casting that we can use to make a number of different rotor sizes with. We just have to do all the machine work on it. So this machine here actually cuts the outer edge, finishes the surface, and also would apply the flange that would mount the rotor. So the nice thing about these long flanges is this can be a left or a right-hand part. It does have our curved vane design, but because of the length of the inner section of the rotor, we can make the flange on either side.
Gotcha.
So with one casting, we can make a left or a right side part. We can move on over to see a nearly finished part. So you can see here, we've done the balance cut. That's what this edge cut is here. So just like when you do wheel weights on a wheel to keep balance, we would remove material from the outer edge of the disc to get the balance cut to reduce the vibrations. You can also see the flange, the bolt holes have been applied, and we'll come back in later and do some clearance cuts
in these flanges. Having continuous flange actually increases the chance of cracking. So you have a little scallop in between all the holes, and that's what actually prevents further cracking, helps the rotor expand and contract.
Wow, that's cool.
So quite a bit different from the raw part that we saw there. Significant change.
Yeah,
See how much material has been removed.
Crazy process to see from here to here.
Here's a full run of brake lines that are now finished and put in their packages, labeled. Pretty much everything we're building here in terms of brake lines, slotted, drilled and slotted sport rotors, those all go up to our fulfillment warehouse at City of Industry, where most of the shipping happens. But a lot of the smaller orders for things like big brake kits would ship out of this building.
Yeah, man, this is an insane facility. It's fun to watch everything here. Like, just from the brake dyno to everything being made over there. I've never seen the casting before of an actual rotor and how big and heavy it is and then shaped down. It's really cool to see. So thanks for touring us around this and showing us what you guys do.
I love to have you guys.
Thanks for helping us stop this Camaro. Thanks, Eric.
All right, talk to you later.
So now that we have all the brakes, rear end, everything mocked up, we brought our friend Chris from KW in, and he's here to help us out with suspension. And yeah, we got some stuff to figure out. I know you guys make a kit for this already.
Yeah, so we make a Variant 3 and a Club Sport setup for it. So you're going to get kind of a hybrid between the two.
Okay.
We're going to have to revalve it, respring it also, because of the extra 900 pounds of weight that you're adding to the front end. So you'll have compression and rebound adjustability. You'll have height adjustment also, so that we can dial in the ride height, kind of get that corner balance that you need set up in. We have a little bit of camber adjustment on the knuckle, so you can dial in a little bit of negative camber, get it all set up. And
yeah, because we don't have too much adjustment here.
No, there's no adjustment on these, so a lot of it's all done in the damper.
Right.
So that gives you a lot of balance, and then especially with what you're trying to do with launching the car, we can change the rebound curve in it so that'll transfer more weight off the line, kind of get going down the road. So there's a little bit of tech that we can play with to make sure we get those.
Yeah, and it's easy for me to throw in because it's the same thing I have on my car. So.
Yep. Super easy. You know how they work.
Yeah, and then the rear is not stock.
Not stock at all. So we've had to make some things in CAD.
CAD. By CAD, you know what? Let's just go back and I'll show them. So kind of a big deal here.
Yeah.
So, this is what we're talking about. Get that somewhat close, whatever. All right, well, we had to make this out of cardboard. This is what you would call cardboard-aided design.
Yeah, essentially.
Yeah, so we have to simulate basically the tire.
The tire. So we looked at what tire they're using, figured out the OD size, and that translates to how much travel you have in the rear end and all the other areas in the back of the car that we have to make a shock for. And there's limits because of the mount and how it mounts into it and how much room you have. So that's kind of how we came up with the dimensions of the dampers in the back, and it's pretty simple once we get all these kind of X factors lined up, so there's no kind of questions on, well, how big of a tire, how low are you going to run it, what type of mounts do you have. So now we have all that data, like it should be fairly easy to get a shock.
More adjustability too.
And a lot more adjustability also.
So you have to simulate it basically as close as we can get to what we're going to run for ride height. And obviously in the back we are going to have to do some more clearancing, and we knew that, but some of the other stuff we had to do is like get as high as we could.
Yeah, we got it as high up as we could to see how much travel we have and where you're going to bottom out and all these other factors, so that way we can build you a damper that works in the parameter of the dimensions that you have.
And when it comes back, we'll install it. We have a few more things to do, so hopefully by the time you guys are done, we're done as well. So
definitely.
Thanks again, Chris.
All right, man. We'll catch you later.
More clearance. Got a really big rear end going in here. That's hilarious. Can't say really big rear end. Big old diff.